So one of the things that really excites me is I think, like whenever a new person comes in to the team, like after their first like 3 months, like, wow, like every month we ship more than like a year worth of time in like, insert your popular, open source project. So there's definitely a lot of fast movement on Lance front. So I think you'll be excited about some of the things I'm going to be talking about today. And then a couple of things of what we're going to be building next. So, what is Lance? Well, Lance is the Lakehouse format for people who want to work with multimodal data without screaming into a pillow. And so, there's a lot to unpack here, but really, I think I want to point your attention to two things. One, what is a Lakehouse format? And then number two, like, what does work with mean here? Like, what kind of work do you do with that data? And, why is it actually better? And, why does it not make you scream into a pillow? So, to give you a very specific example, this is a stylized image processing pipeline that many of our customers or community members go through. On the left, you start with a bunch of images, and these probably live on S3 somewhere as files, and you may want to generate some captions. So maybe use DeepSeek, and like Gemma 3, and you want to caption them but differently. You want to maybe compare them, or like you want to prompt them a little bit differently. And you can generate like the image embeddings. You can extract the width, height, and like the dimensions, and maybe like a small thumbnail through Pillow. And then the captions themselves can essentially you be used to generate to extract tags out of for filtering and search and faceting. And then maybe you can extend this further on where you can generate summaries of the captions, and you can generate the embeddings from the captions. And this table gets wider and wider over time. So currently, if you're just doing this with S3, right, these are raw files that live in S3. That you'd have to put in a vector database. These would probably go in some sort of like analytics database, so you can do filters and do like data curation and exploratory data analysis, right? And then like maybe you'd have to put the captions into Elasticsearch to do full text search or keyword search, right? So now we're talking, and as you get more features, you have to figure out, maybe you have to introduce more things, and then you have to like figure out where to throw them in and how to keep them together, right? So at this point, this is where I have to go scream into a pillow, and this is what Lance is basically designed to solve. So instead of having this in like a bunch of different places and a bunch of different systems, Lance gives you basically just the same table. You can put all of that in. And so what does that really give you, right? It solves a set of really key problems. So number one is that you want to be able to store the large columns, which is in this case is like the images and embeddings, and the small columns, which is the metadata and tags and the dimensions, all of that together. This is not easily done in Parquet. So how many of you tried to store like images and video along with metadata in Parquet before? Okay, nobody. Okay, good. Just use Lance, save yourself the pain. So the problem with doing that in Parquet is you're limited by row groups. So what's happening is you either have to so by default, Parquet's row group sizes are tuned for like the small columns. So then if you're storing images and videos in there, you're going to run out of memory real fast. If then you say, okay, I'm gonna make sure I don't run out of memory, I'm gonna make really really tiny row groups. Then what happens? You don't run out of memory when you write it, but then like when you try to read it and when you try to scan it, when you try to run queries on it, performance really sucks. Lance actually gets rid of the row groups altogether. The data is laid out in a way in pages so that we can traverse both small and large columns very easily. Right. Number two is AI, sort of new AI workloads are very interesting. So how many of you have trained like an LLM before, or like a visual model, or even like a deep learning model? Cool. One of the critical steps in the data loading process is shuffling, right? You don't want the model to always see the same sequence of observations over and over again. You want to have some randomness. With Parquet, what you have to do is essentially in batch, or like localized shuffling. You read out the whole block and you can only shuffle within the batch. And I don't have it here, but there's a recent paper that proves that global shuffling is what gives you better convergence, better model properties. But that's not just not possible with Parquet because it sucks for random access. So this is one key problem that Lance solves. Two is there's a bunch of indexes that we built into Lance so that you can do search and key value lookup workloads really easily, right? Because with AI, search is such like a huge and an important part of your workflow. So in an offline context, if you're doing model training, you're going to do EDA, you're going to be doing data curation, right? And then like if you're, let's say like you're training big model for autonomous vehicles or something like that, you find an edge case. What you want to do is, okay, I want to find like 100 scenarios just like this one, but I don't maybe know exactly how to describe it, right? So I want to do like similarity search and then be able to send that to the labeler. In an online context, of course, as you know, we've been building RAG applications and like AI agents that need data for the like last couple of years. That's really been exploding. So search is huge. And again, that's not really possible with Parquet and the existing Parquet based systems because you can have search indexes that point you to the right rows of data, but if it takes you like 10 seconds to fetch those rows, then it's not it's not very good. And then lastly, with the rise of agents now, you want to be doing things like managing agent state. And there's a lot of like auxiliary data that your agent need access to. And so typically these are accessed in like key value lookup kind of patterns. And so random access makes it really good for those. And of course, so for indexing, I talked about that already. So indexing and random access together is what is going to support a lot of these new AI workloads that you have. And then the column addition is actually something that's sort of like beyond the Parquet scope of things, right? Beyond file format level of things. You remember that picture I showed, right? I didn't start out with that whole table. I started out with just an image, and then I had to add like the captions, and then I want to do some experiments. I added another caption column, and then okay, I want to add some embeddings, and then I added another column, and then let me just experiment with like the top 10 embedding models from the MTEB benchmark on Hugging Face. Well, now I've got 10 more columns. So there's no such thing as like the perfect set of features when you first start out, right? It's always an incremental process. You're always enriching the data set that you have, whether you're building new search applications or training a model. So you want to be able to add columns very, very easily, and you want to be able to do that without copying the original data. And so this is not something that Parquet allows you to do. Actually, this is something that Iceberg sort of allows you to do, to add columns, but you can't backfill that data without having to copy your original data, that column. So, and turns out backfilling is like 90% of the work in like feature engineering. And then, okay, so I've got the pipeline, I've got the data that can do the serving, I've done the feature engineering. So now I've got to do training, and especially if you're working with LLMs or like multimodal foundation models, these are huge, right? We're talking about like running feature engineering jobs on like tens of thousands, hundreds of thousands of CPUs, and then like training on thousands of GPUs over days. And so you're going to have distributed workers, distributed data access problems, dynamic partitioning problems. And a lot of the problems that you run into with Parquet in the training context is that you're tied, like the partitioning scheme that is optimal for writes are not always optimal for reads and training. But like with Parquet, you're tied to you're forced to like have one partitioning scheme. So there's no like other way to efficiently access the data other than at partition boundaries. So this is another huge thing that Lance is designed to solve. And then of course, we don't want to just ignore OLAP queries because we still need analytical queries when we do data curation, we do exploratory data analysis, and we have a structured table. So of course, we're going to support very efficient OLAP types of queries. So when we put that all together, so what do we get? So we get really, really great sort of like data foundations for training. So this was a user report on our Discord, like this happened just yesterday, right? So this user built their own distributed data loader. They have like 150 billion rows in a Lance data set, and they were getting way, way better streaming throughput than what they get from Parquet, right? So this is huge if you're training models. At the end of the day, so what you're seeing with Lance is you get this one table, right, that you can add to that can serve every sort of all these different workloads that you want. And then number two is that we can, when we add columns, these are actually easily versioned. So, this is like a Lance batch UDF where you can use UDFs to then add columns, or you can use to add rows, and these are automatically versioned, right? So I have this table, stylized table that has 2 columns and a bunch of rows, and I've created this table using 3 operations. So essentially, we'll create like creation of the table with the first file, and that's v1 with just column A, and then I added a bunch of rows to column A, and so I still have just column A, and this is v2 of the table, and then version 3 of the table is I've actually added a new column B, and then I can actually backfill that. So um, this is, for model training and even for serving, this kind of versioning history is immensely important because it allows you to have reproducible research. So if you want to say recreate like a model run, you can say, give me the version of the data like as of yesterday, or like as of like the month, as of the time that I did the last, model run or something like that. If you're building like a chatbot or a RAG application and your users report a bad result, right? So how do you know whether that's because you didn't find the right context, the context didn't exist in the database, or that the generation step messed up and there was hallucination? With versioning and history, you could go back and say, run this retrieval on the state of the database at the time of the user request or the user report, and then you'll be able to tell whether the actual answer was in there. Okay, and then some other cool things you can do. So these are our friends at Netflix have built this thing off of LanceDB, where this is a very large video data set, and you can run search queries on it. So for example, here we're searching like elephants in the jungle, right? And we're searching over the text embedding here, but you can, you can just sort of switch to image embeddings and other things as well. And so what good is this for? So for example, like if you're a streaming company, like if you're a Tubi or something like that, you run into all sorts of regulations. So maybe it's like this one country in Europe says you're not allowed to show smoking on screen in your content anymore. So how do you deal with that, right? So it used to be that you had to hire a bunch of people to literally like watch every single piece of content that you have and like mark down the frames where people were smoking, and then you can process it and everything. With a system like this, it literally is just a small search query, and you'll be able to find kind of what we're looking for, right? That person smoking, for example. Okay, cool. So, hopefully I've convinced you like Lance is actually kind of cool. It's the sort of single source of truth, and we're continuing to build this out and grow the community. And so when we put all this together, one question that we get a lot from our community is like, how does this fit into the ecosystem, right? So like I've talked a lot about like comparisons with Lance. Maybe I mentioned Iceberg, and I know there's like all these like storage engines and like compute engines. Where does everything fit? And so I think this is a diagram from Jack that I think explains it pretty well. So we sort of take the sort of Lakehouse stack and we break it down into a bunch of different layers, right? So you have object storage, file format, table format, the catalog protocol, and the catalog service, right? So the protocol is basically just the spec, and the service is the actual service or the project that runs it. And then, of course, on top of that, you've got compute engines. So the reason why we call Lance the Lakehouse format is it sort of traverses a couple of different layers. It's got file format features, kind of like Parquet. It's got table format features, kind of like Iceberg. And then the indexes live in the table format layer. And then we have Lance namespace, which I'll talk about in a second. That is sort of the namespace spec. And so the way to think about it is we're not out to replace Parquet or Iceberg in all of its applications, but it's just to be a optimized version for AI use cases where Parquet and Iceberg are not a good fit, right? So you think left side of this is BI, right side of this is AI. Okay, cool. So there's a bunch of really exciting things that we've shipped recently, just basically in the last month or so, that I want to kind of quickly step through and kind of show you. So number one is Lance format 2.1 is now stable. And we made an announcement recently in a blog. And so I think, how many of you have read or seen like the F3 paper? There's a new format that's come out. Okay, cool. So that's another format that came out that's basically like, okay, we're going to embed the WASM decoders for data, right, into the file itself. Super cool. They did a bunch of tests on random access performance, and they found Lance was the fastest. Unfortunately, they tested on 2.0, and their conclusion was like Lance was fastest because it didn't have encodings and compression. So this is incorrect, because in 2.1 we actually added tons of compression and encodings without affecting random access performance at all. And let's see. What's really cool about Lance 2.1, other than the compressions, is this idea of what's called the 1-2 IOP challenge. So with data, a lot of that data is very deeply nested. So if you have annotations, you may have a list of objects within a picture, then have annotations that are like bounding boxes and labels and all that stuff. So a lot of that nested fields are really hard for random access. In previous versions of Lance, like these could take up to like 5 IOPS operations just to get to one like particular piece of data. And so that gets slow, especially for machine learning data. So we actually kind of redid some of the layout, especially for struct columns, so that we go from this like sequential nested data access to basically at most 2 IOPS to get even the to get really deeply nested field access. So this is actually really cool for machine learning data. And then so we talked a little bit about compression. So here's a diagram of like the compression ratios based on the data types that you see. So I think for AI, if you're doing training models, especially what matters is like, website data, code, like string data and prompts. So this is basically the data type versus the compression ratio, right? So it's the higher is better. So with 2.1, we're actually able to achieve better compression ratios on the data types that matter for AI than Parquet. And, like embed and many of the others, right? Like images are going to be the same. That makes sense, because like images are compressed at the record level. Embeddings, like they're all floating point vectors, right? So can't really compress them. Like there's ALP, but it's not lossless, and it really only works well for like continuous data, which embeddings are not, right? So there's all this stuff. So I think there's a lot more work we could do. I think there's still like many things that we could add to improve this picture. But I think 2.0 we're already sort of hitting that impossible triangle, right? We're faster scans than Parquet. We're getting like way faster random access than Parquet, and now we're also achieving better compression ratio in a lot of ways. So if you look at our docs, if you're interested, the Lance format docs now has a listing of the different compression algorithms and when we would choose to use them or not, and then like the version that they're available in. So these will be changing. We'll add to them over time. But if you're interested, that's where you can go to see a complete listing. So we've been working on the integration layer a lot. So the Lance Ray, we've shipped a distributed full text search and also distributed compaction. So these matters a lot. Like if you have really large data sets. So some of our community members, they're managing search data sets with like, 80 billion rows or 80 billion vectors or something like that, right? Adding to that data set means you have to have compaction and reindexing that doesn't take many days. We shipped Lance namespace. So if you recall from that picture earlier, right, there's this like catalog spec or catalog protocol layer. So we're not going to ship a new catalog. We already have Unity catalog. We have Iceberg catalog. These all work perfectly fine. What we decided to do is ship a project called Lance namespace, and this is a protocol that makes Lance tables compatible with basically any catalog service. So you can use these. You can use Glue if you're on AWS, Hive Metastore, of course. So this is super important if you're thinking about, I have an enterprise data architecture and I would like, how do I do access control and how do I do like cataloging and all of that for my Lance tables? And of course, we've shipped a bunch of improvements on the search. Number one, I'm really excited about is RabbitQ. RabbitQ is basically kind of like, so how many of you like know what quantization in vector or like embeddings do? Okay, cool. So you probably know like there's different quantization methods. There's like product quantization, PQ, and there's scalar quantization, and then there's binary quantization. Kind of RabbitQ is actually kind of the best of all of that. And even better is that it actually works really well with like the higher dimensional vectors. So the difference between like RabbitQ and PQ actually gets more exaggerated as you have higher dimensional vectors. And so what's happening on the hood is like now each vector gets mapped to a binary vector. And then you're basically doing projections onto this like hypercube in the hypersphere. And then the distance computations are based on this like approximation vector plus an error vector. So the cool thing about RabbitQ, which I won't have time to get into, is that one, it makes some assumptions about high dimensional vectors, about that the values are actually clustered around 0. And then that fact means a lot of the errors in your approximations are bounded. So if you look at our results, right, basically this is like as close as you can get to like a free lunch. So if you compare this to like PQ, we're getting better recall by default, better higher throughput, and also a smaller index build time. And so you can kind of look at that as just like across the entire like recall frontier, the RabbitQ just kind of dominates PQ. Okay, and then also sort of like we achieved a 30x speed up in k-means. So, if you understand vector indices, like k-means is a critical part of partition-based indexes, which is the default in LanceDB. So we use a couple of different tricks. You can follow this link to the PR. We use a couple of different tricks: hierarchical k-means and also ANN centroid assignment to achieve this huge speed up, which is pretty cool. And then let's see what else. There's another cool thing from this is a community contribution from Gordon that you see up there. So you've got all this data, right? How do I look at it? And so this is basically Lance data viewer. So if you you can point it to a directory where your Lance datasets live in. So you can get a listing of your Lance data sets. You can select one, see like the columns, and then see the schema, and then you can see like a preview of that data. So I think what's really going to be cool as the next step is like, okay, let's build some querying capability. So you can do some searches, or like you can like filter this data, and you can do a bunch of different data exploration activities in there. So if you want to try that out, you can go to this blog post and basically just pull this Docker container and run it. Okay. I'm going to speed quickly through it. Not going to go into details. If you want to stream data, so Apache Flux is like your streaming data layer for a lot of these Lakehouse formats. So the folks at Flux added an integration with Lance. And so really, I think the secret weapon for Lance for us in the open source is the community. I think we're going to be moving towards better and better community governance as time goes on. We haven't, so you're all getting a preview of this. So we have lance.org, which is a separate domain name just for the open source that is focused on the Lance format. So you can go there to check out the spec, the user guide, a bunch of examples like, hey, you want to train an LLM using Lance. And then we also have a separate Discord just for Lance format. And then, yeah, and then I think we're going to do more than just this. We're going to be publishing community governance standards and then move towards true sort of neutral governance in the future. So stay tuned for that. Right. And then this one last cool thing I thought was really cool is like, okay, when you have this new format that can do a lot of different things and deal with a lot of different data, you have like people from the community can think of really creative ways to use this. So this is again a community project called Lance Graph. And what it does is it essentially can turn your Lance data set into like a knowledge graph, and you can and into like a graph database. So you can essentially say like build a graph, and then like I can run Cypher queries and do graph search. So this is just a very early stage, in our very early state, but this is something that I thought was like super cool. Okay. So the last thing I'll say is we're growing the team. We're actively hiring. So if the talk was at all interesting and you love working on databases, you can scan that QR code, or just come talk to anybody on the LanceDB team.